Hello ladies and gentlemen, welcome to my car rig demo. I'm going to be going over the different aspects of this rig as well as my thought process in developing it. Now right off the bat I'd like to show off the structure of this rig. As you can see over here on the left hand side, um, the rig itself has been brought up into different parts. We have one main controller or one main handler which just contains the entirety of the rig. Within this, I've separated the mesh out from what will be controlling it. That is the different parts, and those parts have been split up into their own subsections. The bones, the controllers, and any other aspect which might be required in order to make this rig run. By doing this, I'm allowed to have ease of access into whatever area of the rig I need. If I need to look at the bones, I can easily just go into the bones, pop it open, and then all of them are laid out, and everything is follows a very strict parenting structure. By using this parenting structure, I'm allowed to on a per level basis modify it in its location in space, its rotation, as well as its scale. Again, this applies to all levels, so anything that's under something else will receive the transformation from its parent. Now, to showcase some of the techniques I used, right off the bat, I'm going to go over here to the side and grab this handle right here. This handle is a main controller, and every main controller affects another controller, which then affects a bone. As you can see here, the armature pumps out, this rack pops out, and the missiles attached to it follow suit. Now, the gate itself has a set driven key. However, once I get rid of the geometry, you'll be able to see the bones themselves, and you'll see these circles, which are NURB circles, as well as the square over here, which is comprised of a CV curve. When we select the bone, we see that they have inherent transformations, and they're translate. Some of them have in their rotate, but that's because they've received inputs from their control curves. But initially, all bones tend to come with translate information. This can cause havoc later on when you're trying to do specific things. Since you're not starting off from zero, you have to adjust for whatever position the bone is in. By creating a control curve for the bone and setting the inputs to that instead of the bone directly, you're allowed to work fresh from a point of zero. Everything's zeroed out, the scale starts at 1. Now, when I bring the geometry back, you'll see that this NURBS curve uses a set driven key, as I stated, while the circles receive MELScript encoding. Through MELScript, I'm telling these in particular that whenever this CV square is modified along the z-axis, it will make the rotation on the z-axis for these become alive, or in other words, move this over here. Another example of what other techniques I've used is first off, real quick, a perpetual motion. The wheels are not being controlled by a master controller. Instead, what's animating them is actually this bar down here, which I'll show you through the MELScript I actually used in it. Once I bring up the expression editor, as you can see right here, if you can read or make this out, it says that the control curves for these will make the bones rotate along the x-axis for every frame that passes at a rate of 4. So basically this is running at 4 times the playback speed. This allows the animator or the user to be able to animate other parts of the car without having to worry about the wheels. It's another feature of making it for ease of use. One quick thing you might have noticed, however, is that certain parts of the car are moving while the animation plays. The front bumper itself is actually boneless. This does not have a bone. What it does have is dynamic weights. These weights have been painted onto the bumper so that when the car runs, it begins to jiggle up and down as if it were, real metal, or at least as close to real metal as possible. In the rear, to achieve a similar effect, I've simply hand keyed and hand animated the bumper. A nice simple example of using two different methods to achieve the same goal. The controls are pretty straightforward on this. It has a controller for the wheels, controller for the gun, and these are children of the main chassis controller. The bumper has a controller as well. The rear has a controller as well, and they have their children as well. And the reason this is done is so that the car functions more realistically. If the car were to, let's say, get flipped on its side, or if it was doing a turn, it would lean a little bit, or obviously uh, do some sort of deformation. By leaning the car over like this, you see that everything follows suit. Having rigged this, if structure was not maintained, parts of the car would just stay in place. That means it would be utter chaos trying to animate this thing realistically. Through an ordered structure, we're allowed peace of mind, and we're allowed to use this rig to its maximum. So that's pretty much what I tried to achieve with this rig: ease of use as well as functionality within structure. Hopefully, this has been a interesting demonstration, and thank you for your time.